I forgot to... what a rookie mistake. Forgetting to hit go live on YouTube. Are you gonna come online? Okay. There we go. It's two separate buttons. I can sing the start at the same time, but then when I do game streams, it would make me go live on YouTube too, so I have to do it separately. I've been trying to read 4.6 for at least 2 or 3 weeks now, and I've just had too much real life things going on to actually get far in it. But even this first example with Laplace's equation, I've had a hard time with. It's interesting that they bring up heat flow, but then talk about Laplace's equation. I assume there's a relationship with the heat equation, but I don't know. Sage, hello, hello. Also, is my streamer bot not working on YouTube? Ugh. It's connected. Is the trigger broken? Streamer bot updated and broke so many things. Okay, let me... test trigger. Yeah, okay, so why didn't that do that automatically? First time early to the YouTube stream. Oh, nice. I've actually been streaming for a few minutes. I just forgot to hit go live on YouTube. You haven't missed much though. Yeah, Green's function. I don't think it'd be interesting for me to try to understand this on stream right now. Yeah. They're my favorite Sage. How long even is this section? Pretty freaking long. A of eta. Laplace was before Fourier. Interesting. Ooh, that's a cool analogy. I like that. When I first learned Laplace transforms, I thought of it as like those types of questions on standardized tests in the English section where you have to like read a passage and answer questions about it. I would always think of the Laplace transform as like taking that passage, translating into like Spanish or whatever language, answering it in Spanish, and then translating back at the end. This is a much more direct analogy though. Yeah, I must have been taught it like that at some point. My memory was just a little bit too rusty. Generating functions? Really? Those have a relationship with Laplace transforms? That's annoying because that's another thing that I've actually already had a bit of an interest in learning about generating functions, but I'm annoyed that I now have even more of an interest in them. That will be a side quest for after I'm done studying, though. Donda's combinatorics. I mean, honestly, that and graph theory are things that I'm interested in, but not anytime soon, at least. Oh, interesting. Oh, okay. So that's, I guess that's been another source of confusion for me. Where when I was taught the Fourier transform, it was only about periodic functions, but it seems like it's not just about periodic functions. And so I've been a little confused about that aspect of it. But this is saying that it is just about periodic functions. Et minus I omega x, essentially a way to encode periodic functions. Oh, yeah, fair. I guess the source of my confusion with that is that, like, this definition of the Fourier transform makes no reference to, like, periodicity, I guess, but I guess you're saying that it's encoded in that. Because the formula that I was taught initially when I was just, like, in my differential equations class was more like this, but separate formulas for sine and cosine. Fourier series are periodic only. Right, I know about series, which I guess is another source of confusion for you, which is what's the relationship between the transform and the series? I have many sources of confusion with Fourier and Laplace transforms. I can do them. I just don't know really what they are. That is an interesting thing, an interesting point though, Catmaster. Hey Naman, it's the slope of x to the n where n belongs to rational numbers. Uh, I was like, that just sounds like taking a derivative. The goal of Fourier transform is to determine how inline the inner product integral sense of function is with a kernel, such as e to the minus I omega x or e to the minus st for Laplace. And that's what we were doing during your series class with playing with the integrals of like sine nx times another sine. Wait, but how do you get the series from the transform, or the other way around? That's what I don't get. Oh wait, no, I think I've done that. I just need to go back through it again. What is Fermat's method slope of x? It doesn't make sense to say x to the n has a slope unless you want to talk about a derivative. Oh, I guess slope of the, okay. Yeah, it seems like it. Just it's like a derivative without ever taking the limit. So it's just like an approximation. It's not an approximation. Fermat's theorem? That has to be the most vague name for theorem. This is for area. There's too many R's in this. Man, we have to go to page 2 of a Google search. That's how you know we're in trouble. Oh, is that like... I guess that's getting the exact value from an approximation. It sounds like what you're saying. Um... Fermat method. Tangent. Transient. Tangent. Anticipated the calculus. Let me post about that on the Facebook. Calculus. You can put it in the Discord. Do a minesweeper. We can do that quick. Just because Naman might need a moment to post an image. I think that example would be pretty helpful because I'm a little confused on how this is supposed to work. Ooh. Oh, I just got... Okay. I got confused there. Also, I can do these a lot faster on my phone, just using my fingers. These buttons are a little small to use the mouse with. Oh my god! I almost clicked that bomb. Nice. Multiplayer Minesweeper is a thing? Is it? Oh yeah, it is apparently. I assume you're just working together on the same puzzle. Oh wait, find an opponent. Huh. That'd be kind of fun to mess with. 3D Minesweeper. Really? I have not heard of that. Oh my god. Oh, the perspective. Okay. No, this is sick. Oh, this is cool. Thank you for telling me about this. Okay, so those two are bombs. Hey, Brian. Be mine. I get it. Yeah. Uh, those two are no. What? Oh, yeah. I'm just bad. This is cool. The hero told me about this. Quiz about how to play. It's not too hard to understand the rules. Honestly, it's kind of a stupid game. I specifically play on this website, the no guessing mode, but normal Minesweeper, there's situations where it's actually really common. Like you can get them multiple times on the same board where you do everything right, but you're in a situation where it's 50-50 or even like 1/3, 1/3, 1/3, and you just have to guess and take your chance. And there's nothing that you can do about it. And so that's kind of a stupid game for that reason, I think. I only know about it because I'm only like decent at it because I'm a fidgeter. I need to always be doing something with my hands, and so I just have the Minesweeper app on my phone that I frequently have open just to occupy my hands, basically. You did these in about 41 seconds. Oh my. Okay, if you're gonna lay the gauntlet down, Zach. Oh, 2D. Okay, never mind. Okay, I know there's a bomb here, which means there can't be a bomb there. By bomb, I mean mine. Same thing. There has to be two there. That one's safe. Oh, this is... Yeah, those are both safe. 3. This should tell me something, right? It should tell me that these are all safe. And if this is a 1 here, these two must... Ooh, no. Tetrahedral 3D Minesweeper. Just wait until we get a non-Euclidean Minesweeper. I don't even know what that would be. Oh! I saw something I posted in the Discord. I promise I'll look at it in a second. I'm just a little preoccupied with this. Okay, so wait. There's a 2 right there. And these two are already occupying that entire 2. So I think everything around that 2 should be safe. Dang it. Okay, well, let me look at the months thing. If that's your handwriting, you have really amazing handwriting, by the way. Seem a lot happier? Oh. Well, thank you. I've been, prioritizing living life away from the computer for a bit and really enjoying it. Okay, so... rename hello. So slope of the secant line is that. Slope of tangent line is that. Yep. Only difference is the limit. If y equals x squared, then you're just plugging that in for f of x. Same with f of a. Fair. And then from, is this arrow simplification? It doesn't look like it. Like, I know it should be 2a from calculus, but I feel like if we're just saying that, then what's the point of this method? Tending to symbol. Oh. Okay, and I guess we could justify that pretty directly. Like, I'm not a fan of just magically knowing that if the point of this is to find it. But if you cancel the x minus a's and then you would plug in x equals a, you can get 2a. Or unless it's just a statement. I don't know. Maybe this is just like a build up into the actual method down here. Maybe I shouldn't overanalyze that. Okay, so if y equals x to the n, do the same setup. Yeah, that's fair. And then, yeah, now you need to divide it out, unfortunately. Do we know... Is x minus a always a root of that? It is? Okay. I'm sure there's a way to... I guess you would actually do the long division, and you can show that way. Oh, yeah. Make a strong point, Zach. Okay, and so when you do the long division, you get that result. I'm just gonna believe it because I don't feel like verifying that. And then you evaluate it at x equals a. Because when you get roots of unity, ooh, true. Oh, because of these exponents line up perfectly. That's the idea? Oh yeah, no, I know the like I could prove that long division if I wanted to, but if that's not the question, then I'd rather not do it. Okay, so this just seems like the answer to your question, Naman, but I assume that you're asking about something else then. Or do you have a question about what's written here? Oh, this is for rational. Oh, right. Okay. And you're asking about real n. I remember this. Yeah. I've looked into something like this before. Um, and I remember it being harder than you would think to prove the power rule for... Oh, okay. So you're asking just about rational. That makes life easier. Yeah, the proof for real numbers is really weird. Um, okay, so this is the question here. How do we deal with rational numbers? The long division argument kind of falls apart here, I think. Like, I can't think of a way to make the long division work by factoring something out first or something. But it feels like rational shouldn't be that much worse. Like, there should be something that we can do. Hmm. Hey, Gianluca. Yeah, you can ask a question if you want. I'm currently working on this one right now, but there's no one after this. And if it's quick, I'll just like do it quickly. Yeah, this might be something that's better to look at someone else's work. Teach yourself limits in 8 hours. Part 4. What do you think about the Italian university level of mathematics? I know nothing about it. um, I haven't heard anything good or bad about it, so I'm not sure. Oh, is it going to be a change of variables? Maybe not. My friend in Italy for information engineering, their math is more pure than I expected. Oh, really, Mert? Europe in general leans more towards pure math than America does, at least. Um, yeah, exactly. I remember that you're from Turkey, and so I don't know what things are like there, or like how math is commonly taught there. Um, so this is where we're gonna start reading from. You did underdegree in Rome? Oh, that sounds awesome. Super is more similar to American. Okay. Um, why are they noting this? Like, sure, Q is just an integer. They're choosing the denominator. Spain for masters in pure math. Ooh. Oh, yeah, I'll drop the link to this in the YouTube chat too. I mean, Spain sounds amazing too, just as a place to live. Um, I do you know if those classes will be taught in Spanish or English or I don't know. Because I feel like even in non-English speaking countries, at a certain level of like academics, they switch to English, but I don't know that. Churros, ham, midday naps. What's not to love? True. I live in Spain just for their culture and football. Oh, nice. I don't care about football at all myself, but they are big on that. Isn't Barcelona a really good team? Or Madrid, maybe? I don't remember. I'm pretty sure that they have a really good team in there somewhere. Huh. This is confusing so far. Saying away from zero is very, it's kind of disturbing to me. Like, just say non-zero. But I guess they're going to do a squeeze theorem thing, and they're trying to justify that. And I guess the absolute value bars here are compensating for like a potential negative sign that this denominator used to take care of. That's the type of subtle thing that I would forget about. Wouldn't you need absolute value bars on this x minus a though? I feel like you would. Taking loads when x goes to a. Isn't everything zeroing out when x goes to a? Oh, wait. No. Okay. They maybe skipped a step, but like, I think they're adding a to the 1 over q to each side of the inequality. And they're taking care of the signs on the way there. Yeah, sure. Sorry, name. This is really tricky. Phobos, hello. Hope you're doing well. Oh man, they did a sneaky multiplying by fancy 1. That's crazy. No, man, I'm not sure if you're still here. Uh, we can try to go through this if you want. I can try to explain it. I think I understand it decently enough to explain it. You are here? Okay. This kind of sucks, but I don't think there's a better answer, as far as I know. Please do? Okay. Um... Yeah, that's kind of where I'm at too. I kind of understand it. Maybe in the process of explaining it, I'll figure out the bits in between. Okay, so where did the p come from in the final step? That's just going back to the original question. They didn't explain that all that well, so let me... I can actually start by explaining that step. Oh wait, why did that cut off? Slim, thank you so much for the raid, though. I hope your number theorying was good. Yeah, and it was your man. Check out Slim Academy's ideas. He's awesome. Okay, so where the P came from on the final step was they first everything before that was just justifying some background information to use later. Once they justified that, they went back to the original question at hand, and then we're saying n is p over q, so that's where it initially comes from. But then to get to this step, they do the good old-fashioned multiplying by something over itself. My Q's look like 9s. It's really unfortunate. And then they switch these two things here. And so that's how they got to this step. And the point of doing that is so they can do a change of variables in the next step. So yeah, for anyone who's just joining us, the question that we're working on is it's basically a proof of the power rule for derivatives in the case of a rational exponent. And I'm following along with the proof from this website, and it's a kind of annoyingly tricky. What was the end goal? Well, I guess let's keep on going through this final piece here. Hey, Kahan. Thank you for the kind words. So let's do that rearrangement. Well, the end goal is to get from this limit to this result for a rational n. And so everything that we're doing in the middle is in the name of justifying that. That's what the end goal actually is. Physics exam on Monday. Just came here to say hi. Oh, nice, Loki. Well, good luck. And then they want this because that's where we're going to use the justification Doesn't it can come organically? No, I would not call this organic at all. And that's just an unfortunate reality with a lot of proofs involving limits in real analysis. You have to spot these crazy, like, plus something minus something, or multiplying by something over itself. It's just something that you kind of have to get used to, unfortunately. These steps aren't intuitive if you haven't seen them before. But it is just how the proofs go. But yeah, then you do the change of variables. Oop. B to the B? Why is that again? Yeah, I think you're right. That's got to be the same exponent. That must be a typo. Because if the exponent isn't the same, then this is just something weird. I do think I spotted a mistake earlier on it in the proof too, so I think it's just like some person who wrote this out, but they made mistakes just like I would. Thank you, Slim. Good to see you too. If there's time between questions, I'm thinking about ordering a new pair of shoes and want to get people's opinions. Because I can't decide like which one I want. So if there's a spare like minute, you know, speaking of like fashion and like looks. Yeah, just like sneakers. Hey Divion. Um Maybe after second step we can try to apply the long division series. No, we can't. At least not usefully. Well, ooh. Oh, can we? That's a thought actually. Yeah. Oh wait, yeah. We don't have to. We can use the previous result here. That's what they're doing. They're using this result here because P and Q are natural numbers. So we can just apply the result directly because these limits exist individually. Okay, yeah, yeah. That makes so then what was all this other stuff that they were doing before then? Maybe just proving that it converges. This actually doesn't seem that hard now. Do B and P have to be like two of the worst letters? Actually, no, they're not the worst letters. U and V are, but like P is just upside down B, and Q is just reflected P. Okay. This actually this is not so bad. Just distilling it down to this. PBQD. True D too in there. So yeah, I was looking at New Balance shoes. Um, because I have wide feet, and it is impossible to find shoes that actually fit me. Or like it's really difficult. There are row in there, true. So yeah, no man, I hope that helps. Honestly, this just seems like a good enough proof to me here. I guess maybe there's some trickiness with like the 1 over q exponents that you need to do some justification with, but yeah. To top your uni? Wow, congrats, Kahan. Well, I'm glad to hear it. You also have white feet that struggle to find. Yes! New ones are comfortable, but I don't find them as stylish. Yeah, they don't look that good. But I feel like I just don't have that many options. I'm also going to be doing a lot of walking around to get to and from class, so. But yeah, no, I went to Nordstrom Rack yesterday, and I could not find a single pair of wide shoes. Hey, Fembox, how's it going? So this is the other question I was posted. So someone in YouTube did. Who was it? Suriname. This doesn't feel like a question that I can do, but let's read it. Just got hit by the number theory train I saw. Positive area. When would it have negative area? I know about negative area in the calculus sense, but there's no coordinates here. So how else would we have a negative area? Like, is it somehow avoiding, like, the bow tie quadrilateral? Like, this would technically be a trapezium? Maybe? But this wouldn't have negative area as far as I can tell, so I don't know. I don't know why, but that's the only thing I can think of. Yeah, Phobos. This might be a Googler. The answer is 8? I have no clue. Maybe. $15 or less. There you go. Oh my god, there's so many questions on this. Control F, trap. Oh man, it can't search inside the PDF. What also where are they getting blurred out? Some of them. Here we go. Those are some shaky lines right there. Oh, come on. Skip. Okay. That's why it was getting blurred. There's very little explanation for this. I'm gonna take a screenshot of it just in case, but I'm gonna keep looking. Is there an answer key on this? Oh. Okay, 24. Allegedly, the answer is 31. It's cooler than California, for sure. I moved here just in the last little bit of summer. It's been in like low 80s, high 70s. It's just about to get to the rainy season though. Like if you look at the weather forecast, I think there's maybe one sunny day in the next 10 days. Man, I don't know where they're getting this from. I'm just gonna link this, I think, because this is some stuff that I just never learned. Okay. Okay, but I guess we have a free minute then. So these are the shoes that I was looking at. They don't seem that bad in terms of the looks. They're nothing special, but like that's an okay color. This one I don't like. This one's also pretty good. This one's good. And this one's like okay, but I don't know. Like it's hard in the first place just to find a shoe that fits. And with this one, I'm not even sure. Like I normally wear like 10.5, but this one they say that runs small. So should I order like an 11? I don't know. Catmaster, yeah, sure. If it's just a for fun question, I reserve the right not to do it. um, but feel free to post it. I think I would need to see this one in person because I think this could look nice, but at least online it doesn't look that good. Like the one that's light, it's just a little darker than this one. Oh, that one? Yeah, this one's nice. Aluminum gray. Nike system. Honestly, Kahan, I'm looking at these because they have wide shoes. Like that's the only reason. I've had a really hard time finding shoes that are wide. We're looking at shoes. No, Lucas. I'm just buying shoes, and I couldn't make up my mind about which one I want. Also, why does the color in that one look so much different than the color in the other pictures? Don does shoe reviews. Mm-hmm. Don does fashion. Tommy Hilfiger? Hilfiger? I don't know how you pronounce it. I did just buy a jacket. I think it's Tommy. Yeah, it is. I just got this jacket to help me out with the rain that's around here. Hilfinger? Yeah, when I saw the store, I was like, ooh, I want that jacket. It was pretty cheap too for being a nice jacket, like 70 or 80 bucks. I've just been on a clothing like buying spree because let me show you a note. I've never been much of a hat person in my life, but it's been like sunny the last like few weeks. I'm like, oh, maybe I should start. And I kind of like wearing hats now. I never really did before, but got my UW Huskies hat, and I kind of like the way that I look in it. So I think I'm gonna be a hat person now, at least some of the time. I think the haircut I have right now like also helps with that. Bunch of oh yeah, so let me actually we have one vote for this color, which I think it might be my favorite too. Because I'm planning to just order these online because you can see if they're available. And there's one store that's like an hour away from me by transit, but they don't have any white shoes in stock as far as I could find. So it's not really helpful to even go to the store. So I was planning to just send an order online and hope it fits. The black ones aren't bad either, but I'd probably go gray. I don't know. Let me bring up Cat Masters. You bought those. Let's see. Hey, we think you're in the United States of America. Take me there. I'm already in the United States of America. You don't need to take me anywhere. Ooh, those do look nice. Alabaster. Ooh, I would get the blue for sure. That's a nice looking shoe. I would wear those. Uh Why is the white so much more expensive? It's double the price? Huh. Um, those are some nice shoes though. Priyanshu, yeah, sure. I'm gonna look at Catmaster's question first, but you can be after that. How do you group the natural numbers into infinitely many groups with no overlap, no number used twice, each with infinitely many elements? Well, there's a bunch of ways. Oh, well, wait, infinitely many groups. Maybe there's not that many ways. Uh, we definitely need to think about prime numbers. It's one of the best websites for clothes in general. Oh, okay. Can you put all instructions into maths instead of just repeat this? I don't know what you mean by that. Like, trying to teach math in a different way? Like they're talking about like math education, I guess, or I'm not sure. Uh, and so I assume we need to use all of the natural numbers. Because my first thought was to just do powers of prime numbers, but that would miss like composite numbers. Oh, like not use that notation at all? Yeah, you don't have to use sigma or big pi. I guess or integrals, but it would be a lot harder to understand it, I think. Wait, so I mean the issue is so like my first thought was like, do well, one would be an issue. Well, maybe not. Oh, okay. Yeah, I was thinking that just saying composite numbers wouldn't be a good enough definition, but I guess it would be. Is it possible to create like a new instruction? Oh, yeah, why not? Um, yeah, like you definitely could. I don't know what it will be, but there's no reason you can't. Oh, it turns out I was misunderstanding the question. Obi, I thought Lucas was asking about like teaching math, but Lucas is asking about like capital sigma or capital pi as like notation, and if you could make your own. I do feel like there needs to be a math streamer like education conference at some point. I remember like Danny was talking about that idea a lot. Um, we and one. We do need to deal with one. If you ask me, one should be a prime though, but I mean, even then, if it got its own group, that would be an issue because it wouldn't be infinite. Stuff like mathematical proof on how to start to write a proof. That would be interesting. Fair, yeah, yeah. What does composite mean? Composite means if you factor, like, say, if you factor 12, it's 2 squared times, well, actually, let me do an even better example. If you factor 6, the prime factorization of 6 is 2 times 3. These are two different prime numbers, so that means it's composite. Whereas 4 is just 2 squared. There's only one prime number involved, so it's not composite. Some alternative math-based conversations of talks at the joint meetings in math earlier this year. Maybe there'll be more at the next ones. Ooh, cool. That... I should look at the definition of composite. I might have it slightly wrong. Oh, and shoot, Priyanshu. I might be able to do that. I think I can. I think there's like a triangle you can make with that. Wait, really? This is the definition? Do I have it completely wrong? I think I'm using the wrong term. I think I have a composite wrong. Yeah, I just have composite wrong. Composite just means not prime and not one. Lucas, the thing that I just said was completely wrong. Oh, shoot, I wasn't showing the Wikipedia page. Yeah, sorry. Yeah, I was thinking about like the Hilbert Hotel type of stuff. Um, yep. Okay, that's my bad about composite numbers. Yeah, Lucas. I guess we could say for all other numbers, it'd be kind of cheesy. But this would be an infinite number of groups with no overlap. Because there's infinite primes is the key. And each of those groups are infinite. So I think this would fit the bill. My favorite thing about this problem is that you've now found a solution. Now that you've found a solution, you've proven the rational numbers are countable. Assign rational p over q uniquely to the pth element of the q set. Oh, interesting. That's what... So there's a connection with the Hilbert Hotel thing then, yeah. Is 2i a prime number? There is a way that you can define that. I don't know if it is... You can talk about whether complex numbers are prime. I don't remember how it works, though. They're called, if you want to look into them, they're called, Gaussian integers. We can Google it together, too. I know that Academy's Ideas has been talking about stuff like this in his number theory. reading group. Yeah, like this is the type of thing that you'd want to like look at. Put 1 in the first set. Put 1 in the first set, put 2 in the first set, 3 in the second set. Put 4 in the first set, 5 in the second set, 6 in the third set. Class field theory and number fields. Oh, cool. Rotel, but for n instead of q. Yeah. Actually, my friend was trying to first solve the problem. I was blown when he wrote it out. What I have on screen or what Fembox did? Put 1 in the first set, 2 in the first set, 3 in the second set, 4 in the first set, 5 in the second set. What's your pattern there? So wait, 1, 2, 4, 3, 5, 6, something. Trying to paint the XY plane with diagonal stripes. Oh. Is the union of infinitely many numeral sets itself numeral or countable? Mert is saying yes, it is, and that makes sense to me. I think it makes sense. Yeah. Approved for the derivative sine of x? Yeah, yeah. You said sine of x equal to I because they're both rotation of 5, because 5 derivatives of sine is equal to sine. Oh, that's an interesting observation. Because the derivatives follow the same pattern doesn't mean they're the same thing. Well, it's not derivatives. That's more of a coincidence, I think. There is a relationship between sine and complex numbers, but it's not quite that. Hey, Aditya. Those diagonals are going top right to bottom left, as I've written them on screen. New background? Yeah, I moved. Top right to bottom left. Okay. Every left branch of an infinite tree, same as Fembox. I know, I'm still trying to put the flag up, Aditya. I need to buy some pins or something. Sometimes you can, Lucas, but yeah, I wouldn't say that they're equal. Yeah, I moved into a studio apartment. The first letters of coincidence different than how coin is pronounced. Because English is stupid. But yeah, you can definitely draw, like, if you draw the correspondence between integers and rationals, you do get these kind of funny, like, arrow shapes, I want to say. Like, it ends up looking something like that. Hey, Neon. How much do they charge in America for a studio? It varies a lot by location. In the place where I live, it's like 13 to 1500 US dollars a month. But if you live somewhere like less in the city, it can be like half that even. And there's more expensive places where they would charge closer to 2,000. Neon, I am okay. Is there a way to find a vector space if you graph sine of x and its rotation? That's So like imaginary numbers are like vectors in a way, not entirely. Sine, I mean, the issue with sine is that it's kind of one-dimensional. Like there's only one variable. So you could use sine to like talk about, oh, this is a terrible circle. To talk about like any vector on a particular circle, like to describe that vector and that vector. These are terrible. I'm drawing this here. Like any vectors that all have the same magnitude, sure. If you want to talk about like the angle between them and taking the sine of that, but Schrader-Bernstein theorem. That's my stab at it. Yeah, yeah. I guess your vectors will be kind of limited, I think, Lucas. I think. Oh, okay. I can see how this would be helpful. Yeah, that's a nice theorem. It doesn't start for another like 2.5 weeks, 3 weeks. Shoot, Priyanshu, are you still here? I kind of forgot about your question for a while. And then Lucas was also asking about the derivative of sine. Caster, thank you for the question. I might leave it there for now. Got some good discussion though. I was here when back week before last. Yeah. My friend, Daisy friend, JNC Central is studying, and he's not starting until October. That's even crazier late. Yeah, yeah, it's kind of like makes me nervous, but it'll be cool. Oh wait, this is a greater than or equal to. I thought it was a less than. I was assuming we could kind of logic this one out. Like if x is 0, there is no solution, right? Oh well, 0 is x good, but if x is 1, there's no solution. So we can discard a lot of these, I think. Oh, that's an idea, Mert. Yeah. It could be easier to count the number of cases equal to and the number of cases less than and subtract those out. That's a good idea. I still want to try to do it directly, but That's a neat thought. So these all have to be at least 30, right? Like, they all have to individually be more than 30, otherwise there's no solution. Sharing all fun math things today anyways. Found a proof for why limit xa definition of derivatives equal to limit. Oh, good, yeah. Uh, I remember figuring that out too. Oh, and sorry, yes, ChatGPT said find sine of x rotates like a helix around the z-axis. Yeah, I think it would. Maybe. Geometric is a volume between two planes? Maybe? Maybe between four planes, to be honest. 60, 60, 30. Yes. But if even one of them is 29, there's no solution. XA version prefer the H0 one. Yeah, I usually prefer the H to 0 one too. It is the one I was initially taught, which helps, but I just like the H1 more. Hey, Najaf. Yeah, and so that's called a change of variables, and it's a really common thing to do in proofs. So it's good to get used to them. It's completely valid though. Oh, wait, yes. 60, 60, 30. Okay, so it sounds like PhD, you're figuring out a way to like iterate through all the cases. Yeah, I can think it was like kind of you have three buckets with a certain amount of water each, and you just like kind of pouring the buckets into each other. Actually, count the cases by fixing the terms. That might be the play idea. How am I supposed to learn 50 plus check identities within the weekend? I don't know, Najaf. I'm sorry you have to do that. That doesn't sound possible. Um, is that trigonometrics? Sine tan, because okay, yeah. So yeah, trig or like trigonometry. Yeah, that's a pretty common weakness. Um, the Jeff's calling 54, 56. So yeah, if we fix x to be 60, what do we get? 59, 31. We basically are going to subtract one from here, add one to here until we have it flipped, right? I don't know if this technique is actually... It's not going to help us when none of them are 60, though. Fixing the term of x, counting the number of times. Yeah, okay, maybe it does help. Because, like, if we can think of, like, we could do a shift now where x is 59, and presumably these will follow. I think this could be, like, one less case or something. Which will make it trickier, though. X plus y plus z equals a for some 180 greater than equal to a greater than equal to 150. Yeah, the more I try to do it my way, the less I like it. You might be onto something better. It's JE Advanced. Oh, ugh, I'm googling it because I'm getting a little bit done with it. JEE is the university entrance exam for India, and it is needlessly difficult. Well, maybe not needlessly difficult, but it's just extremely difficult. And I think the person who asked the question isn't here anymore. No, Lucas, it's not like it's not deep math. It's just they use really vague identities and like tricks that no one has heard of, at least outside of people who are studying for JEE. And so I really don't enjoy the questions because they just feel like trick questions. Um, as long as we're always changing X, I think we'll be safe from that peach tea. I think. Well, ooh, no. There will be double counting. There will be a danger of double counting if once we try to make the claim that we could have done this with like Y or Z as well, keeping one of those fixed. Like wouldn't be a symbol just multiplying by 3. Yeah. Becomes probably just C of NM summation by basic sum properties on it. Fair. J is pointless out of 2 million. The top 3,000 rankers choose computer science as the major without previous interest in the field. They just want a high package. Fair. They are real numbers. The volume will be useful, but they are integers and won't work. Okay. Oh, it's response to Fembox's idea, I think. Always write a program. Write some code so you can judge it. Um, that's true. I bet that NumPy will provide a really efficient way of doing this too. With arranging arrays. I don't know exactly how it would look. I know a bit of programming, Aditya. Lucas asked about proving the derivative for sine of x. Do you still want to do that though? Because the person who asked this question isn't even here, I don't think. So I'm okay with putting a pin in this. When I was studying math to get back on pace with my class, it also felt like they were JEing when I was studying trig. It's yeah, it's okay as in like you don't need to see it now. I don't mind either way. You do. Okay, okay. So yeah, if you want to prove the derivative, oh, this isn't right. There we go. So yeah, that's how I would set it up. The first step is to use a trig identity on sine. I'm gonna have to look it up because I can never keep them straight. GAKAO? I'd never heard of that one. I'd never knowingly done a problem from it. Sine cosine plus sine cosine. Oh, it's the Chinese JE. No. As far as I know, I don't have any Chinese viewers. If I look at the analytics, there's quite a few Indian viewers though on YouTube, which is great. I just wish they had an easier test so I could actually help with the questions more. With correct prompt, ChatGPT can solve combinatorics questions very easily. Really, Mert? Minus 1,000 social credit. It's kind of interesting to hear. ChatGPT's just been getting better at math. It's not like completely there yet, but it's only going up. Yeah, sometimes you do need to do stuff like that, unfortunately, Lucas. Oh, Adia, this is a separate question. I'm just moving on from this question above for now. Let me go to a new page to hopefully make it more clear. Lucas is asking about the derivative of sine, the proof of it. So we're just going through that now. A couple things that does wrong, but really not a lot. Fair. That's cool to hear, Mert. I've definitely seen it do a competition integral, and as far as I could tell, it did it correctly. Okay, and so what we're gonna do, I'm gonna rearrange the numerator. I'm gonna take this term and factor out a sine. Personally, I think it's more likely ChatGPT gets worse over time as it restrains on more of its own output. Oh, sorry, retrains. Yeah, that's like there's a term for that, right? I forget what it's called, but like that death spiral for AI. That's possible too, I guess. Is America having inflation? Do you feel inflation in the market? Depends who you ask. We're in a weird place. Economically, I don't know about inflation specifically though. To be honest, I'm actually I mean, things are definitely weird here, but honestly, I haven't heard much about inflation numbers specifically. Change my mind. ChatGPT is ruining our society. It's like an Asian sibling choice. Do something better than you. Okay, I don't know about the stereotype there, but I think ChatGPT poses a lot of problems, in part for that reason, but I don't know. Don't imagine the AI revolution is here. It's all linear algebra, no real artificial intelligence. I mean, I don't know what more you would want though, Cat Master. It's still, it kind of acts how you would expect AI to act. Sorry, I should be explaining what I'm doing, not just writing. GIGO, I don't know what that is. GBP is currently 4/3 USD, USP 5/4. That's right. Yeah, the currency is becoming an issue. Zeration, you didn't know about. Okay. So change them a bit. Usually makes them better. Sometimes I'll make a mistake. Garbage in. Oh, garbage in, garbage out. Okay. Yeah, that makes sense with AI. Okay, good night, Aditya. 100% accuracy at HMMT? Oh, I forget what HMMT is. Does he still understand? Okay, good. So what I'm doing here is I'm going to... I should do this in 2 separate steps. Yeah, so first I'm going to split this fraction up based on the numerator. And we have copy and pasting, so let's take advantage of that. And with limit properties, we can split this up into 2 separate limits. So we actually do that in the same step too. Okay. Harvard MIT. Oh, right. I had that's what it is. Yeah, that'll be an interesting thing to see. Obi. How companies deal with that. Okay, so these limits only care about h. X is completely irrelevant to the limit. And so for the purposes of this limit, sine of x is just a constant and it can come out front. So I'm going to put the sine of x out front. Same thing over here. The cosine of x is essentially a constant. It can come out front. This you also understand. Good, good. So I assume you're going to ask about the really tricky part that I was going to try not to explain, which are these limits here. So these are really kind of, I would call them like well-known limits, where when you take a calculus class, you're going to encounter these and at least have to know the result. And so the answer is that this limit here, I believe, is 0. Yes. And this limit here is 1. Okay, good. So I would go with that argument there. Because the actual proof of it is, like, we can go through it. I have to look up how it works again. Proving these limit, like, this limit in particular is pretty tricky. Yeah, I remember that's the idea. I think that the easier thing to kind of understand it intuitively, sine of x looks like that. Well, sine of h. And we're talking about h going into 0, so we're interested in this area around the origin. And right around the origin, sine is approximately linear. Like, the line y equals x looks a whole lot like sine around 0. And so you can say, because we're taking the limit as h goes to 0, this approximation becomes relevant. So we can, like, kind of estimate it as the limit as h goes to 0 of just h over h. This isn't a proof, but it gets across the idea of why it is. And of course, h divided by h is just 1. Strasson's method of matrix multiplication? I haven't heard of that, Cricket. I'm sorry. Ariva Rasu, you can put it there in the YouTube chat or my Discord. If it's JE though, I can't do it. I'm just gonna tell you now. On the trig circle, you can find that for really small h, sine of 0 is the same as just 0. Therefore, sine of h is also the same as h. That argument doesn't always apply, Lucas, I think, because it depends on how fast it goes to 0. I'm not sure if that argument would always work for other functions. MathX, a peak sheet. I don't know how to do that question, I'm sorry. Why not 0.37h? I assume that's a leading question, Puika. And so, like, I don't know if you're trying to get at something specific here, but the slope of the line is just 1 for like the tangent line to sine it at 0. If it was 0.37, it would look it would be like a flat line and not a very good approximation for sine, I guess. I don't know if you can. I mean, maybe you can epsilon delta this. Usually you don't use epsilon delta to prove this, though. This is one where you use other theorems to prove it, like squeeze theorem. So it's going to be built on epsilon delta, but I don't think you actually use epsilon delta. That's the point of derivatives. F of 0 equals 0 does not imply f of h equals h. F of h is about f prime 0 times h. Oh, okay, so maybe you're talking about that in response to like what Lucas was saying. Yeah, I would love to use a Taylor series. I don't think Lucas has... Actually, I remember I've talked to Lucas about Taylor series, but I don't think Lucas has actually learned that in his class yet. And I imagine there's the same concern with, like, you're not supposed to use L'Hopital's. Like, it would just be like a demonstration, I guess, not a proof, because for the same reason you're not supposed to use L'Hopital's for that limit. I imagine you wouldn't be supposed to use... You wouldn't be allowed to use a Taylor series. But I also heard people who don't buy that argument and that L'Hopital's is fine. I don't actually know. Yeah, so I'm a fan of this is basically using a Taylor series approximation here without actually saying it. And so I'm a fan of this kind of like intuitive way of explaining why the limit is 1. It's a little bit more difficult to do with cosine, right? Because like I could definitely do the series with that, but cosine, like the approximation for cosine is just 1. I can't immediately think of a good intuitive explanation for the cosine limit. I wonder, is it just a change of variables from the sign limit? Maybe that's how we should think about it. Because, yeah, I bet there's a change of variables. Yeah, I guess that's getting harder to do with, like, with a sign approximating line, you can visually see it. That's a little bit harder to justify with the parabola, though. Is an epsilon delta bigger than 0 such that epsilon is equal to delta over small h? Ooh. I have to unpack that. Let me... Okay, yeah, so Puika is saying that, like, I guess I'm right to be suspicious of using Taylor series to actually prove it. And so, Lucas, I'm going to warn you that you usually want to avoid using epsilon delta at all at all costs because it's just very difficult. It's better to use properties of limits if you can. But we can go down this road and see what happens. Well, okay, I think there needs to be an edit where it needs to be for all epsilon greater than 0. Um okay, so I don't think I agree with your justification here. Because they do share a point, but it's more than that. Because you could also say that y equals 1/2 h shares that 0, 0 point. But that's not a good approximation for sine. Because it looks like that, right? It's not just about sharing that one point, it's about kind of following the curve. So it's necessary that they do share that point, but that's not enough. Hey, color cone. Let me see what Zach linked. Half angle? What? I think it'd be a lot easier if you just use no, not Lichess. like this identity here. I said that was my first thought. Or like do a change of variables so you get this identity. Do one of these answers say that? Oh, is that the simplest proof? I think I remember doing a proof like this for Zach's class, actually. um, yes, Lucas, basically. The issue with that is that we're trying to prove what the derivative of sine is. And so we can't really talk about derivatives yet. And that's why this gets so tricky. But that is the condition for why it would have to be. Like, you would need the derivatives to be equal also. Color we've been talking about proving the derivative of sine using the limit definition. We've been a little bit all over the place. We've also been talking about the limits sine of h or sine of x over x and cosine x minus 1 over x. And then we're getting to like epsilon delta for this, but I'd rather not go there if I can. And then we're kind of like also scratching the surface of Taylor series with why sine of x is approximately x. We've been a little bit all over the place, but I'm kind of intrigued to try. Like, I feel like if we know this limit for sine, I feel like we can use it to prove the cosine limit. Hey, Shashwat, thank you. Yanis, or wait, yeah, yeah, Yanis. Hello. I hope you've been well. It's been a minute. If we're just given this limit, can we prove this limit? Yeah, I think squeeze theorem is fair game. That's the usual way to prove the limit up there. Wait, let me. Yeah, that's true, Buika. You want a general proof for the derivative sine of x. Not the derivative sine of x in the place of a, b, where a and b are less than 2 pi. That's what we're still doing. Like, this is going to be a general proof for sine of x. We have to deal with the h's, though. We have to, like, get rid of the h's, I guess. So there isn't a restriction on x, but h is going to be around 0, and we have to use that to our advantage. At least try to. Busy dealing with life in uni? Fair enough. I'm doing well. I moved. I'm going to start on a master's in applied math in, like, 3 weeks. So I'm excited for that. So we know sine of pi over 2 minus x is equal to cosine. That's the identity I want to use to get from here to here if I can. That's a proof that I was seeing, Territar. I feel like this identity should work too, and so I'm just exploring that. So I want to take x equal to pi over 2 minus u, let's say. Maybe it won't. Maybe this is a bad idea. So if x is going to 0, u is going to pi over 2. No, I don't think this is. I don't think my idea is right. For some reason, I thought we would get a -1 that pops out if we did this, but we don't. So no, never mind. Yeah. New background. That's my bed right there. I want to get my flag hung up behind me. That's been a project. I did get new lights, but they're very hard to see during the day still. So that'll have to be a nighttime thing. And I have to program them still. Let's welcome that server. Geometric proof the derivative of sine is cosine using the unit circle implicit function theorem. Ooh, okay. Yeah, I'll have to try and dig it up. Hey, Poison Mouse. Make it work using an angle sum identity to break the cosine into 2 sine cosine. That's true. We could investigate that. Actually, yeah, I think you're right, Catmaster. I really feel like this approach should work and be a lot simpler, but I don't think it works. Mert is saying to try u equals 1 over x. Ooh, yeah, that's a completely different way of thinking about it. Wait, does that substitution work? So if I start from here. Yeah, I just wanted to avoid the sine squared thing, but I guess that is just the way. I guess there's a plus or minus issue here, but I'm just going to ignore that. Well, okay, no, this isn't that simple. I feel like the numerator never exceeds 1, so you should be able to use the squeeze theorem. Ooh. No, what if cosine is -1? It could be 2. Well, I guess it won't be for the positive limit. For the negative limit, maybe, or... I don't know. Multiply it by cosine of x plus 1, limit won't change. Cosine of x plus 1 over itself? Oh, I can see how that might help. It'll give you Pythagorean identity. Oh, well, I was trying to see if I could get a better proof for the cosine limit. I don't think I can, though. Probably the sine squared thing is the best. Is the move. Or like I think this is what Puika is saying. More or less. Yeah, territory. I got a little bit stuck on that. Mouse, I was just playing around with I thought I had an idea to prove this limit in a simple way. It didn't work out though, so we've just been kind of talking about different ways of proving that. We kind of got off on a tangent here. What was that thing that Lucas said? Because this all came from... Okay, Lucas hasn't said anything since. This all came from a question from Lucas, so I want to make sure that I was answering that, but... Uh, so I've heard that it's bad form to use L'Hopital's and Taylor series because these limits come up when you're trying to... So where this discussion started is the question was prove the derivative of sine of x using the definition, the limit definition of a derivative. And so if the goal is to prove the derivative... Oh, wait, and sorry, once you apply the limit definition, once you go through all like the steps, you end up with these two limits. And so you shouldn't use Taylor series or L'Hopital's because those involve derivatives, and we haven't yet proven what the derivative of sine is the issue with that. Yeah, so that's basically what we started with mouse, or like something like that. You forgot, honestly? No worries, Lucas. Yeah, I guess you have something else you want to ask about, let me know. If not, I'm gonna find something to work on. Jens, or maybe Jens? Hello, welcome in. We doing well? Why did I ask myself these types of questions? What definition of cosine are we even using? That's a fair question. I think like the definition of sine is kind of weird, isn't it? Like it's harder than you would think to actually define it without complex numbers. Oh, this is a mathematician's Google search right here. Definition of sin: an immoral act considered to be a trans. Ugh. Okay. Sine. Um. Yeah, I mean, this is the way that it's commonly taught, right? That it's just opposite over hypotenuse, but that's not... Is that an actual, like, math definition, though? I thought that was the problem. Where if you want to actually, like, rigorously define sine, it's not that easy. Maybe this is better? I don't know. Mathematics class, I think common approach in uni, we defined it by its power series. Oh, yeah, I think that is the common approach. Which is kind of funny. Like, it's kind of backwards, right? Because like, you do have to start somewhere, but that does feel a little bit backwards. Can we talk about numerical methods? I don't know that much about them, Shivam. If you want to ask about a specific thing, feel free to let me know, but... You can show that cosine of 1 over x minus 1 times x is bounded by y equals x and y equals 0. Okay, I mean, that the approach is getting a little bit out of hand there, Tar, but there probably is, like, it must be possible, I'm sure, with something like what you're saying. It's getting kind of complicated, though. Usually the problem is to define sine and cosine in a way that we can work with the expressions. Right. The sine and cosine are really motivated by plane geometries. So it's kind of hopeless to expect a fully satisfying one-dimensional description. Fair. Yeah. Some old hippie caught another hippie tripping on acid. Is that like... Oh yeah, that's like Sokotoa, but different. Dr. L, hey! How's it going? Can you use the trig circle? The problem, yes, but it doesn't actually help you do like algebra is the issue. I think it's what color cone is saying. You need to look for a different definition to actually like do things with, I guess. My opinion, the unit circle definition is probably the best motivated definition. Okay. Just think of sine as primitive. That's probably for the better, yeah. Or think of e to the I theta as primitive and sine coming from that. How's school going? It hasn't started yet. It's not starting for another 2 or 3 weeks. The orientation is on the 22nd, and then classes start like that week, so. What is this character? What? Is that sideways beta, or is that omega with a bar? The lemniscate constant? I know what a lemniscate is. That sunglasses? Yeah. This is Gauss's constant? Is the Gaussian gravitational constant just capital G? No? Oh wait, it's I'm okay, it involves G. I'm getting way off track. Oh, oh, it's the equivalent of pi, but for a lemniscate. Huh. But how do you say the symbol? Like, what is it? Cursive variant of pi. There's cursive in other languages? I guess that makes sense. I never even thought about that. Ah. Oh my god. Okay. Cursive pi. You learn something new every day. Coolest constant in all of math. You love elliptic integrals so fascinating. I'd love to learn more about them. Because they come up in orbital mechanics, right? And that's something that it's on my list of things that I'd like to learn about at some point in my life. Russian cursive is wild. I'd never looked at it. Probably varpi, yeah. Can we find the root of 24, but not from standard methods? We solve this with the help of Newton-Raphson or bisection. The root of 24? Do you mean the root of a polynomial? Just as like endless U's? Let me see. Let me Google it. Russian cursive. Oh my god. It does look like endless U's. Can you actually read Russian cursive? This is like me when I have to sign things after paying with my credit card. That's what that looks like. Call it bi because it's worse than pi. Makes you want to leave. There you go. X squared minus 24? Maybe. Every Russian becomes a doctor. From cosine 1 over x greater than -1, subtract 1 for both sides. Oh, okay, yeah. Territor. There. Oh, yeah. Yeah, I know exactly what you're talking about. Color cone, the little thing that moves back and forth. Seismometer? Is that what they're called? What did this come from? Oh yeah, the definition of sine. Or seismograph? Thing that measures earthquakes. Seismometer. Okay. I keep getting ads for university I'm already in. Are they stupid? Yes. Which is showing you ads for university? That's kind of funny. Rex, hello. How's it going? Why am I still reading this? Ooh. Ah. Those ads really worked. They did. Yeah. Yeah, sure, Lucas. Had an elementary reunion today. Got drunk with my old teachers. Ooh, that's cool. I never gotten drunk with a teacher. One of my professors in college had a tradition of taking, like, her classes were very small, and so she had a tradition of taking her students out for pizza after classes were over. And so I've had a beer with her and a bunch of the other students, but we definitely were not getting drunk. Wonderful photos. Oh no, Rex. It's been really fun to explore. I don't feel homesick at all. Seb, you're welcome to post it. From Triggs proves that shaped sine of x is less than tan x. Yeah, I remember that. That's basically how it goes. Yeah. So what is Lucas doing here? No, this is not a good proof. And I'll tell you why. I can use your same logic with different functions and get a contradiction. So I can say that the limit as x goes to 0 of x squared is 0, and the limit as x goes to 0 of x is 0. But when I go to divide these two things, we're going to get just x. And so we're going to get 0 instead of the 1 that your logic would have predicted. And so that's why I'm saying, like, the speed at which things go to 0 is important. Sine and x go to 0 at the same speed. But if you square x, that's faster. You had 8 beers and some miscellaneous alcohol on top of that. Oh my god, syntax. Also, over the weekend, I did just finish half the section in my book for limits class. Nice. Which talks about how some of the fundamental theorems in real analysis are really equivalent to some classical definitions. Interesting. We were the first class I taught, so I think we're a special case. Went over this in my limits class. Need to explain more. Live, love, squeeze theorem. As part of the reverse mathematics program, John still has a book on it. The idea is to figure out the minimal set of axioms to prove results. They're important math. Oh, cool. Same for 2x and x. Oh yeah, that might be an even simpler example. Okay, so Lucas, I guess let me start by repeating the proof that you did. So you're saying that the limit of sine of x is 0, the limit of just x is 0, and so when we go to divide them, well, actually, the more that I look at it, I'm not sure how your math has justified this equality right here. I don't see like anywhere here why sine of x is equal to x there. But just because the two functions both go to 0 doesn't mean they're going to divide like this. That's right, exactly adds 0, sine is 0. But when you do limits, you actually don't care about the point itself. You care about like around that point on either side of it. So the actual value at 0, it is important, but it's not that important. What we really care about is just to the side of 0, like just here, and like limits talk about the behavior around a point, not exactly at the point necessarily. And so we have to care how well this line matches with sine. And so like Puika is saying a good counterexample here is that if we instead made it 2x, we're going to get a line that looks like that. And all the logic that you said here would still apply, but you're going to end up with the wrong answer if that's suddenly a 2x. But it would still have been valid if you like did everything before it with 2x. So like if that's a 2 and that's a 2. Seen the geometric proof of the derivative of sine? I don't think so, no. I've seen like the geometric, like how you use the squeeze theorem for the limit with sine of x over x, but not for the derivative. Syntax, can you send over chat or send over Cord? I guess either is fine. If it's complicated, do it over Discord. If not, chat is fine. I forget how this goes exactly. Asymptotically, sine of x is equal to x near 0. Yes. That's exactly what we want to show. Yeah, you can show that with Taylor's series, but since we're talking about like just defining derivatives in the first place, I'm trying to avoid Taylor's series. Shouldn't reverse mathematics. It's pretty cool. Do the standard reference, which is a book by Simpson, which is a hard read. Proves under the preface of the differential forms book. Oh yeah, and so Jens or Jens, sorry, I'm going back and forth. Academy Useful Ideas also streams about math, and there's a whole, and because I saw your first time chat here today, so I like to let new people know that there are more math streamers out there than just me. Maybe you already know them, but just in case you don't, there's a whole bunch of people who stream math there. The list keeps getting longer and longer, which is a good thing. What I'm doing is a derivative, not a limit. Yes, but the derivative is kind of here in the background when we're doing the limit. Um, there's something really important about x specifically, not 2x, not 1/2 x. And so it has to do with derivatives, but it's not good to say derivatives yet because we're trying to prove what the derivative is using limits. Let me go to Desmos. So the reason why it's okay to use, well, I guess like, it's okay to use, oh, nice. Stuki is awesome. The reason why it's okay to use x in this limit is because x is so close to sine of x around 0. You can just see it visually. But the logic that you're using is just that they intersect at 0, 0. And so that's not a good enough condition. You need more because 2x has that same intersection point, but it's a terrible approximation for sine. And it's going to get you the wrong result in the limit. So just sharing that point isn't enough. And it seems like that's the only thing that your proof is based on. Yeah, go for it. I'm probably going to spend a little bit of time on syntax's question here. But we can keep talking about this after. Nitro, I think you would just cube each side, wouldn't you? So you would do 3 cubed is 27? Unless I'm missing something. Whoa, what is this notation? Oh, wait, okay. I thought this was a point at first. And then I was like, what is an interval union a point? But no, these are all just intervals. Oh, I guess you're right, Jens. Yeah, that's actually fair. Oh, color cone. I just saw you post that PDF now. I'll take a look at it later. Okay, so to find such a function R to R such a f of A equals B, f inverse of B equals C. Can we just say f of C equals B? It's a little bit confusing. So what does this mean to map an interval to an interval? I guess the entire function is equal over that interval? But how does that... there's some transformation stuff that's happening here though, right? These intervals are different lengths, right? And one of them has a gap. Is this a limit question? It just feels like an analysis question. Sine is cosine. Oh, okay, okay. Wait, no, I'm confused. Like, a function is taking an interval of real numbers and returning another interval of real numbers? That's so strange. The image of your interval by your function f who takes a real number gives you back a real number. Okay. So the image of A happens to match whatever the function is at B, I guess? Okay, yeah, that's a good example, color cone. Thank you for saying that, because I think I'm imagining the wrong thing. Okay, so the points between -2 and -1 get mapped in the image to 0, 1, union 2, 3. Okay. Now I understand what they're actually asking, I guess. Okay, territory, yeah, that's a good example too. Um, I assume we're going to need to do some piecewise things, right? Is that cheating? I hope it's not cheating. Um, so let's just work. Let's get the first condition nailed down, I guess. And I'm not even going to think about the second condition yet. So what's like the stupidest way that we could fulfill this? Um, yeah, I would like to draw something too. I just don't know what to draw. This is kind of hard. So if x is between, say, -2 and -1.5, we can map that somehow to 0 to 1. So we could say like -1/2x would get us between 0 and 1, would it? Not exactly. Yeah, I was just planning to interpret that second condition as f of c equals b. I hope that will be right, but maybe not. I guess we need an offset, right? No. Well, this isn't quite right. This interval is length half. I want to map it to an interval of length 1. ChatGPT? I don't... f of f inverse of x isn't necessarily x. Oh, because of domain issues? Am I cooking? So this maps -2 to 0. That's good. I need to make it map -1.5 to 1 is the issue. It definitely does not do that, though. Maybe it needs to be -2. I don't think that's still right. Oh, with your parabola example. Yeah, fair. This should be... I feel like this should... Like, my strategy here is to just figure out a linear function that maps the first half of this interval to 0, 1, and then get a different linear function. Okay, yeah, this is gonna be helpful, right? Because this is basically two points, and I can just make a line. -1.5, comma 1 to 2, 3. That's my strategy to meet the first condition. The second condition I still don't know about yet. But like, we can treat -2, 0 as a point, and -1.5, 1 as a point, and use just point slope form of a line. Yeah, for C, I was imagining like we might need an arctan or something. Uh... FA. A minesweeper? We can do a minesweeper. Second one of the day, actually. We're doing well, FA. Bam, bam, bam. No, oh my god, I'm so bad. Not like, can you, but I must. That's true. The redeems are set in stone. I'm honor bound to do this minesweeper. Bam. Okay. Not bad. Do a Sudoku? Oh, I'm so bad at Sudokus though. Um, sin of x less than x less than tan x for x between 0 and 180. What a shitty notation with trig. Yeah, I think that is the trick though for what you do. Don't flag mines. Yeah, there's just kind of. I think there's been some versions of Minesweeper where you have to flag all the mines in order to win, but um, if I can just look at in an area and instantly know what's mined, then I don't think there's a point in flagging. Set a constant function f of x equals c. Oh. Yeah, maybe that's a good strategy. Yes. Sweep around the flags, left and right mouse. Oh, interesting. Wine the Windows to Linux translation. Oh, I've heard of it. I don't have any experience with it. Lucas. I think the answer to that is that you would separately consider minus 180 to 0 and show it has the same result. And it should. In a proof in a textbook, they would normally just write that as like a one sentence thing. Like, equivalently, you can consider x between minus 180 and 0 and find the same result. Like, they would call it like trivial. Okesters. You feel like you did nothing? Me too. Actually, I saw plans tonight, so I don't want to stream for that much longer. I can keep it going for a little bit, but yeah, you have no more energy left for that. Oh yeah, no worries, Lucas. Get some sleep. Coffee stream. That'd be cool. But no, tonight I'm gonna be seeing a some metal bands play at a bar that's by me. I know at FA the nerve. The coffee reward? What would the coffee reward be? Like, would it be like I have to drink some coffee? Will there be karaoke after the show? I don't think so. I think that bar does do karaoke also, but I'm not embarrassed about singing, but I don't feel inclined to do karaoke. I don't know. Nerve just means like arrogance, I guess, in this context. But yeah, bye, Lucas. To work, for some reason, there's a mine clone in the files. I assume some software depends on it or something, so my uni entrance exams, we need to boot to this exam OS. Train on Linux, but need some Windows programs so I had Wine installed. We have to find a way to launch the Minesweeper in exams. What the hell? That's so funny. I think that was like famously a thing with some retro video game, or maybe not retro, but there's some game where like an entire previous game was contained inside of it because of the dependencies. I forget what it was. Yeah, Syntax, with the question that you asked here, did you get what you needed from chat? I know I didn't do too much, but if you want, I can keep on trying to answer this, but since you switched topics, I don't know if you already got what you needed. Yanis said that is a really good idea with just using a constant function that makes life a lot simpler. Okay. Sounds good. I do want to see what Colorcone posted earlier about the geometric proof for the derivative of sine. Yeah, Puika. We're just saying to use the constant function to satisfy the second condition. Right? That was the idea. To satisfy the first condition, you definitely need something discontinuous, it seems. Maybe even I don't know. That yeah. Cruz, hello. I'm doing good. How about you? Oh god, this is a little bit hard to read, but consider the equation of a unit circle in R2. X squared plus y squared is 1. Parameterize. Is that U0 for a circle? I don't know how to graph it. I was trying to figure out in my head how to graph it, Puika, and I don't know how. Has Jasu? No, I haven't seen Jasu this stream. We were just talking about syntax errors question on screen here. But we've at least made some progress on it, and syntax is gonna try to make some progress with it. And so we're just switching to something that Colorcone posted in my Discord, just that shows a geometric proof for why the derivative of sine is cosine. So I was just curious to like try and read through it quickly. You'll be out to try your stuff and things. All right, syntax, enjoy. Hope it goes well. Topological properties are preserved under images. Something cringe I wrote a while ago. Okay. That's yeah, this is like calculus. On screen here. I can't read what that is. So this circle is a subset of something? Oh, that's kind of funny. This is using the same interval notation we were just talking about, right? A little bit? Not exactly. U0 is the shaded part of the circle. Oh, okay. That makes sense. This is the... Oh my god, this is way harder than I thought it'd be. It's 7 pages, too. Yeah, it's a little bit hard to read this. But the end goal is just this. Derivative of sine is cosine. Oh wait, you know, okay, this makes sense. So I was expecting, like, when Colorcone says geometry, I think it means something different when I think of geometry, and that's why this is harder than I thought it'd be. You here just for the vibes? Hell yeah. I'll take it. Parameterize a circle with arc length. Fair, yeah. An oriented arc length, okay. Oh, this is like, this reminds me a little bit of, action. It's not quite that. Need points to make me do things, yeah. Oh, thank you, Cruz. I appreciate it. The definition of a radian? Oh, really? Oh, that makes sense. I never actually learned the definition of a radian. It's only ever taught in high school, and I missed that day of class. So, dude, I have to pee so bad. But I don't want to go AFK because I feel like I'm gonna end the stream soon anyways. No, FA, if you're gonna start streaming, you got to learn to hold it in, because the stream is more important than taking care of your body. Shug, 556. Hope you're doing well, dude. Empty chair streams sometimes get more views. I mean, yeah, if the alternative is me being in the chair, I can see that. Oh, shoot. The Knowledge Fellowship, thank you so much for the raid. I completely lost track that a seminar was happening. I hope it went well. Welcome in, everyone. I'm Don. I do actual like math help streams. We're just looking at something that the color cone sent me, which is a proof that the derivative of sine is cosine, but the hard way, because you know it's just fun. Pigments in the history thereof. Oh my! I'm gonna have to go back and catch that. Then that sounds cool. When's the bathtub stream cruise? Very soon. I'm sure I can fit a bathtub in my little studio apartment here. You shook. But yeah, well, welcome in, everyone. So we just got to redeem to do a minesweeper. So let's do that quickly. No guessing mode. Also, there's a lot of goofing off here. It's not just hardcore math all the time. And also, starting on a master's in applied math in just under 3 weeks. So I'm excited for that. It's hard for me to talk and play Minesweeper at the same time. No, oh my god, I misclicked. I'm a lot faster on my phone with a mouse. I have to really slow down and make sure I don't click the wrong square like I just did there. We were just looking at like a 3D version of Minesweeper earlier in the stream too. It's actually not, it's a little bit different, but it's not too different. Yeah, if anyone hasn't seen a math stream before, basically, there we go, 52 seconds, not bad. Basically, what I do at least is I just kind of sit here and wait for someone to ask me a question. And if there isn't a question from chat, then I find something to work on. Or I play games or just run my mouth. Oh, we got a Rubik's Cube redeem too. And so right now it's a little bit of a slow part where we were looking through this, but it's not like the most important thing in the world. Best Minesweeper player I've seen. I might be the only Minesweeper player you've seen, but I'll still take it. Thank you. Okay, so I also have redeemed to solve a Rubik's Cube. Where's my timer? Right here. Okay. First, I'm gonna scramble it. I'm knocking everything over. So this is just scrambling it, not solving it. Oh, Territar, thank you for posting that. I'll look at that in a second. Oh, you know what? And I should do a shout out because I'm not the only math streamers out there. There's a whole bunch of us. And the list keeps getting longer and longer. The brand is Dayan. I ordered it off Amazon when I was in high school more than 10 years ago, so I don't remember the exact model, but D-A, I can spell it in chat. I really like it. It's held up great over the years, but that's at least the brand of it. Okay. Scrambled cube. I get time to inspect it before I start. Okay. I messed up a little bit. Okay, though. This is a sloppy solve. Sloppy, sloppy, sloppy. Yeah, I can do a lot better, but I'm a little bit out of practice. Yeah. Thank you for the redeem. Oh, do you cube too? Puyuka? Ah. Oh, nice. That's the linear function that I was searching for. I do have a collection, yeah. The only other one I have on my desk is this crazy looking one. It's a 7x7 Rubik's Cube. And it is harder than a normal 3x3, but it's more tedious. Like there are some new things you have to learn, but it just takes a lot of work. It's another thing I used to occupy my hands when I'm just like watching YouTube or something. I can grab my other ones in a second. I can send this to the person who asked it, Territar. Thank you for making this. What did you use? Use a rational foot function for the last piece. Interesting. Chess PvP stream? I've done them. I play chess sporadically sometimes, or just like randomly. But I don't know, I've always had a weird thing with streaming chess because it's I don't want chat to help me because that's you know cheating. But if chat can't help me, then it's just kind of lame. So I haven't been able to figure out a satisfying way to stream chess because I have to keep like yelling at people to not help me because I don't want to cheat. Let me grab my other cubes. They're just right here. These ones I hardly ever mess with, so I've forgotten, or I've lost my muscle memory for solving most of them. Oh, it's just a different cube. I don't like it though. It hasn't held up well over the years. I have a 4x4, which even is a little bit different than odd. So 4x4, you need to learn a few more new things. I have, this solves almost just like a regular 3x3, but it's a tetrahedron, I think is the name of the shape. 12 sides instead of 6 sides. That one's not actually much harder though. This one, oh, this is another Dayon cube, but it's not good. This one, it's a 3x3, but instead of different colors, the pieces are different sizes. And so it's kind of trippy to try and solve it. Oh, this is like a Rubik's brand Rubik's Cube, and these are terrible. Never buy these if you want a speed cube at least. And then my last one is a cute little 2x2. Look at it. It's adorable. You can solve these super quick. I haven't done them in long enough though, so I don't remember how. Yeah, that's my collection there. Function is a standard map for 0 to 1 to 1 to infinity. That's fair. Yeah. They don't need to help you if you are playing against me. Yeah, that's true, Epe. So far, I'm sure you're on your way up though in the chess world. You have a bot that takes chat's move. Oh, that'd be super cool, Color Cone. I wonder if there's something like that exists. And I wouldn't care if there might be people like use an engine or something, but I wouldn't even care that much. There has to be something like that. I'll have to take a look. Tetrahedron. Oh, yeah, I think you're right, Peach Tea. Yeah, the 2x2 isn't trivial. You do have to learn some different things. You can do it quickly though. You want one of the tiny little cute ones? Yeah. Let me before I forget, let me send this link to Syntax. Okay, I just posted in Discord. Okay, I have too many tabs open. Okay, I have a lot less tabs now. Okay, so let's try and quickly get through this, and then unless someone else posts a question, maybe I'll try and pull a quick question from somewhere else and then wrap things up. I have plans tonight, so I can't stream for much longer, but I'll have to keep going for a little bit since we might have some new faces here from TKF. Oh. Honestly, I think I would need to do a lot of thinking about this to understand. This construction here. Yeah, it seems like I didn't verify it for myself, Syntax, because I still don't feel that comfortable with the question, but I just wanted to pass it along since Teratar was suggesting it. No worries, though. I think the constant idea probably works, too. It sounds like it. Okay, yeah, I think I'm going to give that one a rest, because words and things. So I have been learning complex analysis. I could pull a question from here. Yeah, I've looked at arc length parameterization before. It's just been a minute. We could look for a Fourier or Laplace question, I guess. And also, if there's someone who's lurking here, I'm happy to explain why 2 plus 2 is 4. There's no question that's too basic or too easy. It's just that the discussion tends to naturally go towards higher level math, because a lot of people who look up math on Twitch they either already know or are interested in higher level math. So oh, there are uncountably infinitely that doesn't make sense questions that are too hard. This might be a good exercise. Is 2 plus 2 commutative? Under the usual definition of addition, yeah. Maybe there's some other definition that it doesn't. Okay, this is our definition of Laplace transform. The second definition will be the one that we want for this question. I want to look at where they did this for the Fourier transform, though, because I think it's a similar argument. Here we go. Integration by parts. Right. Okay. I think we have what we need to do this question now, then. Sure. We're starting... Actually, I didn't even need to copy in the second screenshot, to be honest, but we're here. So we're starting with this. I guess we're going to immediately apply integration by parts. We'll take the derivative of the exponential. We'll take the integral of f double prime minus s e to the minus sx v is f prime x. And then it's uv minus v du. Should be careful here because that's evaluated from 0 to infinity. Wait, what happens to you? I assume it's going to be 0. But how do you justify that? I mean, well, yeah, but we don't know what f prime of infinity is, right? Or 0. Is that just okay? Do we just live with that? I feel like we shouldn't. Wait, actually, I do want that screenshot. There's... Oh! Yeah, you're right. Oh my god. Dude, I have to use the bathroom so bad. It doesn't grow faster? Oh, okay. Okay, you know, I was trying to say this for after the stream, but I'm just gonna take a quick bathroom break. Be right back. I can't tell you how much better I feel after doing that. I was holding that in for a hot minute. Is the music still playing? So just quiet? It's just quiet. Okay, Tertar is right that uh this transform only applies to certain types of functions. And if we want to justify... Shit, how do they justify it for Fourier? Can I just steal that? Nope. So I don't think so. So what are the conditions on F for a Laplace transform? Oh, Artsy Chickadee, thank you for the follow. What is this? Oh, here we go. So what does that say about the limits? Oh, okay. Well, I guess... This is probably the fact that we need here, but... We don't quite have this exact situation. We don't have an integral, and we have f prime. Exactly, Dr. L. Okay, if I just pretend that that's 0, do I get the right answer? I probably... Oh, wait. I probably don't. I should get f prime of 0. So that means the infinity part must be... It must come out to be 0. That's the only thing, because... Yeah, okay, so how can I justify that? Well, okay. We know that 0 to infinity, e to the minus sx, absolute value f of x, is finite. We can actually integrate this. What a terrible infinity, oh my god. If we do integration by parts, I'm just going to pretend like there's no absolute value here, because it's inconvenient to me. And in math, if you don't like something, just erase it. It's the best way to do math. Oh, this still isn't the exact thing that I want. Let's write it out in case it somehow is, but I don't think it's helpful to what I'm trying to show. So we know this thing is also finite. Is that really helpful, though? What I was going for was that this looks like that, but not really. There's an integral. Ghost Skywalker, thank you for the follow. Alright, I think you're getting deleted. Okay, so I'm just, I don't quite know how to justify it. This should, like, in this part, the bit from infinity should be 0. The bit from 0 should just give us f prime 0. I guess minus f prime 0. I might have to look up how you justify that, though. This bit, we do integration by parts a second time. E to the minus sx of x 0 to infinity plus s running out of room oh yeah, that is where it comes from, right? Integration by parts. Okay, so for the same like I'm gonna struggle with this limit too. But we know the result should be minus s f of 0. So whatever we get from infinity should be 0. And whatever we get from 0 is just, I mean, that one's more straightforward to see. That's just 0. This is the definition of the Laplace transform of f. It has an s squared in front of it. And Laplace transforms get to wear a little hat. Minus s f of 0 minus f prime 0. That should match. Good. Okay, well, I glazed over one part of this, but the rest of it I did pretty well on. Like I said, glazed over two parts, but they're basically the same part. Okay, I do think that has to be it for me for the day, though. Oh, wait. Territory, if the limit of that wasn't 0, the integral leads to condition cannot possibly converge to 0. Oh, okay. That's fair, yeah. In like series, that's like the divergence theorem or whatever it's called. Not divergence theorem, but like whatever. I guess that makes sense. Yeah, that's the thing that I'm nth term. Yeah, yeah. I guess the same thing would go for f prime. Like for this one here. Maybe that's justified. I don't know. Yeah, okay, that's fair. All right, fair enough. I think it's gonna have to be it for the day, though. Thank you, Tartar, for the help with that, and for the help in general with the questions. I don't have a plan for when I'm gonna be back. I should be streaming more next week. But we'll see. Depends what I have going on in real life. But yeah, so I cut the YouTube stream off here, and then on Twitch we'll look for a raid. So Territory knows who's here on YouTube. Thanks for being here.